Hey there, ChemC enthusiast. Rion is here, and I've got some thrilling updates from ChemC Academy. So we're excited to unveil our latest feature and online treasure trove of resources and quizzes, and also exams spanning not just chemistry but also delving into the realms of biology and computer science. At ChemC, we believe in providing comprehensive educational experience aligned with the IGCSE Edexcel curriculum. So you're able to get the IGCSE Edexcel curriculum here. And now you can access a wealth of materials tailored to these subjects, all conveniently available on our website. So it will be updated very soon, and the news will be broken very soon to you all, so you can access all tutorials, videos on our YouTube channels, quizzes, examinations. So you can sign up now. Visit my bio or the pop-up in the left right corner of the video. So we have from insightful quizzes to in-depth examinations we've got on your back in your academic journey. But that's not all. We are taking it in a further step by sharing engaging lessons videos on our YouTube channel. Like it's having your own virtual classroom. So are you ready to dive in? Head to the top right corner of our website or check out the link in my bio to sign up. And I think ChemS is not just an academy, it's a holistic learning experience designed to help you excel in chemistry, biology, and computer science. So, guys, stay tuned for regular updates and let's make your learning journey with ChemC even more exciting. So, see you guys in the virtual classroom. And today we have a good lesson for a lesson ready for you all. So, let's focus a bit because it might take time to understand it. And the topic we're going to discuss today is energetics. Energetics, have you all heard? I guess most of you have heard it. So, as I was, so energetics is normally is a study of energy changes in chemical reactions and normally plays a crucial role in understanding the fundamental principles of chemistry and how energy is transformed and transformed in various chemical processes. So today we are going to discuss about exothermic and endothermic reactions. And long ago I've done a detailed video, so now you can the pop-out you can see you can access the detailed video on exothermic and endothermic reactions. Today we are going to cover up everything in brief with some several examples, and we are going to dive deep in this lesson. So exothermic reactions release energy to the surroundings, and they are normally categorized by a negative change in enthalpy. So we're going to do these ones. Enthalpy, what is enthalpy, and later on. So normally enthalpy is represented by delta H. So delta H. Exothermic reactions is normally represented by a negative sign. So as you can see, it's a normally negative sign because energy is given out. Okay. Endothermic reactions. Endothermic reactions are chemical reactions that absorb energy from the surroundings. So the enthalpy change is going to be positive. Plus delta H. Plus delta H. So there are some examples here. So let's discuss some small examples on exothermic reactions. So normally neutralization reactions are exothermic and stuff like that. So endothermic reactions include photosynthesis and dissolving ammonium chloride. So dissolving ammonium chloride, it's a good example because it's used as a coolant when normally when you dissolve ammonium chloride, imagine you get a beaker and there's water in it. You had a sample of ammonium chloride and the beaker becomes cool, right? So it's an interesting lesson, that part too. And we might be able to do the experiment too. So we have to discuss some of the advanced ones now. Drawing energy profile diagrams. Now, drawing energy profile diagrams, you have to understand it clearly because it's kind of confusing. So let's dive deep in. So you're drawing energy profile diagrams normally like this. The y-axis normally mentioned as the energy in joules and the x-axis the reaction progress. So normally actually the rule is you normally put the reactants here. So let's label this as reactants. So this is going to be the reactants. And in an exothermic reaction, so the energy initially should be high. So why? Because it's an exothermic reaction, it releases energy. So the stored energy in the bonds, normally when we have imagine we have a chemical substance, and normally the energy is stored in the bonds of the chemical reactants. So when they are released, they lose the energy. So this line is going to drop somewhere here because the energy has been lost. This normally, if we draw a line from here to here, this is known as the enthalpy change. And this is going to form the products. Normally, the products are shown after the reactants because reactants form products. Okay. Now, if we want to show the activation energy, it's the minimum energy for a successful coalition Docker so that the reaction happens. So, we'll erase this so we have space. So, when we're drawing the activation energy, you go like that and a drop. So every time, each and every time, the activation energy is positive. So it goes like that. That's an exothermic reaction. So each and every time they give you a reaction, I've done a small mistake. So the enthalpy change should be negative here. I mentioned it, but not put it here. Delta H negative. So imagine they say in the question, it's negative, delta H is equal to negative 10,000, sorry, 1084 joules. So it's an exothermic reaction. You have to mention the value here and draw this diagram to get full marks. Now let's see how the Edexcel curriculum gives you marks. Normally they give you marks for like the smallest thing and it's annoying. So we have to know how to score the best by doing everything. So mark in the axes, you gain points. Mark in the enthalpy change, you get points. Activation energy, you get points. So that's how we get marks in Edexcel curriculum. They mark normally each and everything in your paper. And now let's see how to draw an endothermic reaction energy profile diagram. So in an endothermic reaction, the reaction normally has energy, less energy. So reactants has less energy. And the products have greater energy because it absorbs energy from the surrounding. Okay, so to form now, let's see this. To form bonds, they release energy. Okay. I'll explain you all that later after this. So products, then you will understand everything in detail. One moment. So products are going to be here like that. So let's erase this. So we have space for the diagram. So you have the activation energy here. One moment. Okay. So you mentioned the enthalpy change here. Now here the enthalpy change is positive. And we draw the activation energy like that. All is positive. You can put A for activation energy. So each and every time they mention positive enthalpy change, then you get endothermic reactions. Mark in the x-axis, you get marks. There we go. That's how you get marks. Now let's discuss why do we require energy for bonds and for bond breaking. So imagine there are two carbon atoms combine to create a bond between them. To create a bond between them, it requires energy. It releases energy, sorry. It releases energy. So it's an exothermic reaction. So already the carbon bonds are formed and it requires it to be broken. One moment. One moment, sorry. So if this one should be broken, then it requires energy from the surrounding. Then it requires energy from the surrounding. Sorry for the sounds. So, then it requires energy from the surrounding so that they will gain enough energy to it to be broken. So, always for bond making, so bond making or bonding, it is exothermic reaction. It releases energy. While bond breaking, it's and endothermic reaction. Again, bond making exothermic, bond breaking exothermic. Just remember that, and you all require the theory. So there's like a big short note available for you all. I'll show you a sample of it. So